We're interested in comparing the proportions of male and female high school students in Wisconsin who always wear their seatbelt. In a sample of 712 males, 615 of them say they use their seatbelt. And then another sample of 641 females, 578 report always using their seatbelt. We want a 95% confidence interval for the difference in the population proportions of male and female Wisconsin high school students who report always wearing their seatbelt. And does this interval then suggest that the proportion is higher for either of the two groups? So taking our numbers that were given, we can get our two sample values. P1 hat will be the 615 out of 712. That's 0.8638 if we round to 4 decimal places. For the females, we have 578 out of 641, which is 0.9017. So just glancing at the sample values, we can see the proportions higher for the females, but we want to know if that still happens in the entire population. Then when we do the interval using the normal distribution, that z-based inference does require us to check our conditions. We have 4 conditions that we need to check, 4 numbers we need to calculate for this case. So all these things I jotted down need to be at least 10. If you take N1 times P1 hat, you'll get back the 615 yeses from the first group. If you take N1 times 1 minus P1 hat, you'll get back how many people who said no, which would be the 712 total minus the 615 yeses, so we have 97 no's. For the females, we had 578 yeses, and then the ones who do not wear their seatbelt, the total of 641 minus those 578, the no's would be 63. These are all greater than or equal to 10, so our conditions check. And it does need to be all 4 of these things holding. So our confidence interval will be the difference in the two sample values, plus or minus our z. 95% z was 1.96. And then we have the square root of 0.8638 times 1 minus that value over that sample size, which was 712. Plus, then we have 0.9017 times 1 minus 0.9017 over that sample size, which was 641. So this difference in sample values is negative 0.0379, plus or minus this whole thing is 0.0341. So we get an interval with a lower bound of negative 0.072 and upper bound of negative 0.0038. So this is our 95% confidence interval for the difference in the two population values. Notice that this interval is all negative, so negative, negative. So what that tells me is that that value that I'm capturing is a negative quantity or less than 0, so P1 is less than P2. So what we can say is that at the 95% level, the population proportion who always wear seatbelts is higher for the females.